This is a video for the Algebra 2 Blended Course Unit 1 test review. Not every question on the test review is on this video. If you need help with any of the other questions, you need to check the key posted on Canvas or ask your teacher for help. So we're going to start here with numbers 1, 2, and 3. Number 1, 2, and 3 wants you to decide whether or not these graphs or ordered pairs or tables represent a function. So to start, when you have a table, you need to decide whether it's a function by looking at the x values. You want to see if any of these x values repeat themselves. Because remember, the definition of a function says every x has only one y value. So we want to see if any of the x's repeat so we can determine if there's more than one y value for that x. Well, when I look at this table, it looks like none of the x's repeat, which means they all only have one output, so this is definitely a function. Excuse me. In number 2, to determine if the graph is a function, you need to use the vertical line test. Now, the vertical line test says that if I draw a vertical line anywhere through the graph, if it crosses more than one time, then it fails the vertical line test and is not a function. If the line had only gone through the graph one time, then it would be a function. But this one fails, so it's not a function. When I look at these sets of ordered pairs, it's a similar kind of rule to what we had in the table in number 1. You look at the x values. None of those x values repeat, which means they all only have one y value that matches, so number 3 is a function. All right, when I go to number 4, 5, and 6, we're now looking at function notation. When you do function notation, you need to make sure that the letter of the function f here matches with the function that you're going to be inputting. So I'm going to match up the f with the f. The number that is inside the parentheses here is an x value. So when I find f of -2, I'm going to put -2 into f for x. So I will be taking -2, make sure you put it in parentheses, squared, plus 5. Now -2 squared is +4 plus 5, which gives you an output of 9. So you have an input of -2 and output of 9. On this next one, it also says f of 0, so I'm still using that same function of f. The 0 is in the parentheses, so it's an x value. And you're going to put 0 in for x, square it, plus 5. Well, 0 squared is 0 plus 5, which gives you an output of 5. Number 6 here says h of 1/2. So you need to use the function of h. That 1/2 is in the parentheses, so it's an x value. So you're going to put 1/2 into the x value. So h of 1/2 is going to give you -2. Now instead of x, you put 1/2 in the parentheses. -2 times 1/2 gives you an output of -1. Right. All right, so now on this next problem, we are going to work the other way. This time it says we are given the function h of x, and we need to find the x value when h of x equals 16. Well, notice, first of all, it says find x. So I don't know what x is, and the 16 here is not inside the parentheses. That means the 16 is the answer, the output, or the y value. So what you do is if the function h of x is equal to 16, you're going to take your original equation, -3x plus 1, and you're going to set it equal to that 16. That's going to allow us to solve the equation so that I can get x by itself. To solve this equation, all I have to do is subtract 1 from both sides. I'll get -3x equals 15. And then we have to divide both sides by -3. You get an answer of x equals -5. That means the x you're looking for, when I put negative 5 into the function here for x, I will get 16 as my output. All right, couple multiple choice here. Let's talk about domain and range from a graph. So this graph has multiple choice question, and remember, domain always is the x values. So you need to go left to right. Well, when I look at the left of this graph here, there is an arrow, and that arrow is going towards negative infinity. So when you write negative infinity, you always have to put a parenthesis. Well, that allows me to eliminate choices B and C right now because they don't start at negative infinity with their interval. So I really am between choices A and D. So I choose the right-hand endpoint of my graph. This right-hand part of my graph goes all the way up to this x equals 4 with a closed dot. So I have a square bracket, which is answer A. For number 17, for the range, we do the same thing. Remember, the range is the y values, but you start at the bottom of your graph. Okay? The bottom of your graph here is at y equals 5 with a closed dot, which looks like it's going to be choice C. But let's double check. This arrow then is going up, 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 up forever, up towards infinity. Infinity gets a parenthesis, which is exactly what we have in choice C. All right, we have one more question to do here. We're going to do features of a graph, number 19. So let's start with just evaluating the function here. It says find the value for each. F of negative 5. F of x is the graph over here. And that negative 5 is in the parentheses, so that is an x value. So you go to where x is negative 5 on your graph, and you say, oh, I have to go up to 7 to find my output. At 0, x is 0, I don't have to go anywhere. The output of that point is 0. At x equals 2, you have to go up 1, 2, 3, 4 to find an output. At an x equals 5, you have to go down negative 2 to get to an output. So all of those, when they give you the x value, you just go to that x value on the x-axis and count how many go up or down to get to the graph. Now the next one's a little different. It says, what values of x solve the equation f of x equals 0? Well, remember, that 0 is not in the parentheses. So that 0 is a y value. So I'm going to draw on my graph here where all the y's equal 0. That's your x-axis. Right at that line, that's where all the y's equal 0. And it looks like there are 2 spots on my graph where the y's equal 0. Those ordered pairs are right here, 0, 0, and 4, 0. That means the x values of 0 and the x value of 4 both give us an output for a y value of 0. Now I have a very similar question in part C. Part C says how many values of x? So a little bit different. We want to know how many, but how many values of x solve f of x equals 7? Well, again, that 7 is not in the parentheses, so it's a y value. So I'm going to go up on my graph to where y equals 7 and draw a line. That line, if I look here, crosses the graph 2 times. So that means there are 2 values of x. They didn't ask you what, they just said how many. There are 2 values of x that solve that equation. All right, let's finish this up. Interval notation for domain and range. Domain is, again, your x values. So you go from left to right. If I look at my graph over here on the left, it has an open dot, and that x value is at negative 6. So because there's an open dot, you're going to put a parenthesis. Now, you go all the way to the right here, and notice on the right of this graph, there is an arrow that is going to the right forever and ever towards infinity, which would also get a parenthesis. When you do your range, those are your y values, and you start from the bottom. Well, on this graph, again, we have an arrow that is going down forever and ever, and that means it's going down towards negative infinity. And your graph, this time, does have a highest y value. Stops right about here. That's at y equals 8. There's a point at that value, so it gets a square bracket. All right, we need to determine if this graph is a function. Well, it passes the vertical line test anywhere I go. The graph only crosses a vertical line one time, so it is a function because of that, because it passes the vertical line test. All right, that's the video for your test review. If you have other questions or you need more help on that review, go ahead and check the key on Canvas or ask your teacher for help.